Okay, this is June 2016, paper 1, question number 7. A student watches a demonstration of total internal reflection of light in a semicircular glass block. They've made some notes, and what they want us to do is say whether they're right or wrong for 2 marks. Light changes speed when it is internally reflected. We know that's wrong because light never changes speed during reflection. Every ray entering the semicircular glass block is reflected by total internal reflection. We know that that's wrong because you have to be above a certain angle before you are totally internally reflected. So it won't be every ray. If I equals 0, the ray does not deviate. Well, that's true. If it just goes along that line, then I would equal 0, and it would just continue straight through the block. The refractive index of glass is bigger than the refractive index of air. That is true. Jewelers cut jewels so that the internal reflection is more likely. Light enters along AB and leaves along here. They want us to join B and C up. And there's 2 total internal reflections. So it's going to come in along here. I don't have a ruler. You should do this with a ruler. Now I know total internal reflection that the angle of incidence should equal the angle of reflection. So I want to make sure that those 2 angles are the same. And if you did, using a protractor, you would find that it bounces along this line. And then again, angle of incidence equals angle of reflection. So it should come out along there. My drawing isn't the best. You should be using protractors in order to make sure that everything is equal. Show by calculation that the critical angle for a refractive index of 1.5 is about 42. So for n equals 1.5, we're looking for the critical angle to be 42 degrees. Our equation is 1 over n equals sine of the critical angle. So if you want to work this out, it'd be sine to the minus 1 of 1 over 1.5. That equals 41.8, which is about 42. And there would be our 3 marks. If you're not sure how to do this, check with a math teacher or check with one of your teachers, but we're just basically taking that sign down. It becomes sine to minus 1, but it multiplies this whole thing. It wouldn't just be just for the n. Explain why the quantity called refractive index has no unit. So if you're looking at it, it's sine I over sine r. It's just a ratio. It's a ratio of 2 things, so it doesn't have a unit of its own. Or you could just say that a sine is a number or it is a ratio of the units cancel out, something like that. Okay, so what they do then, the graph shows how the critical angle varies with refractive index. Add the point 1.5 and 42 to the graph, so we're looking for it to be along here, and 42, so we're looking for it to be there. How can you tell that the point 1.4 to 42 is not anomalous? It follows, it follows the pattern or fits the trend. So follows the pattern would be fine. So it follows the pattern of the other data, so I know it wouldn't be anomalous because it's continuing on that pattern. Suggest 2 reasons why the axis of the graph do not start from 0. We have no origin here, so it's 1 and 20. So it's because if you started it at 0 here or 0 here, it would be quite a big graph. So we have to have the idea, they're looking for the idea that a reduced scale gives a better use of the grid. That idea that a reduced scale gives a fuller grid. We'd use more of the graph paper. Remember, every time we ask you to hand in a graph, it's always going to be over half the paper. So this one, we're using as much of the paper as possible. Oh, the really good one for the second mark could be angle critical. So the critical angle, they've just done it in a weird way, greater than about 20. So here they're looking for the critical angle varies with the refractive index. So you could say that angle C, the critical angle, is greater than about 20. So we would allow that the critical angle would never be below 20 degrees. It's never 0 for sure. So we'd never start at a critical angle of 0 degrees because there is no material with a critical angle of 0 degrees. The other one you could have is that the refractive index is more than 1. So we could put that in here. Refractive index is more than 1. It's always going to be more than 1 because air is the one with 1. Anything is, that would be the refractive index for air. So anything above that would just be 1.